All right, ladies and gents, here we go. We finally have reached the promised land. We've gotten all through 8.6, which was basically if quadratic, when graphing quadratic polynomials, if you graph them and they're already in vertex form, life is good. You get all the information and everything is easy to find. Let's show you. So here's the idea. So I'm going to show you this. So consider if someone said, hey, I want you to graph and sketch all that goodness, okay? And that goodness that they're talking about is I want you to graph, labeling the vertex, axis of symmetry, X and Y intercepts, which most of the time will just say intercepts, okay? But they give it to you in this form. Okay, and there are multiple approaches, okay? There are multiple approaches you can have, okay? And I went through this one kind of in the other video, okay? But you have to do some work before it gets to be in this cute little form that looks like this. And this is easy, okay? Because then the problem really takes off for us. And then we can actually say that the vertex, just a reminder of how we find the vertex when it's already in standard form, is going to be the opposite of this number, -1 and 8, right? And which means that then the axis of symmetry would have to be x equals -1, okay? So that's something to keep in mind, okay? We know that it's opening downward because the lead coefficient's negative. I always like making, I don't know why I always make my coefficients negative too. There's something wrong with me, okay? The Y-intercept, easy to find, okay? All we got to do is make y 0, okay? And if we can't do this in our head, we could go to the side and do this. It's okay. I get -2 times 0 plus 1 squared plus 8, and that's 6 is what I got, okay? And then I got to find my x-intercepts too, which, like we said in the last video, you may have some, you may not have some, but bottom line is that we can find them, and remember, if we're looking for the x's, that means we know the y has to be 0, and we're looking for the x's. So y is 0, and then let's go ahead and solve this the best that we can. And again, we're not going to multiply this out. It's already isolated for x is by itself. Let's capitalize on this. This is good. I'm going to subtract 8 over. Okay. And then I'm going to divide by the 2, which gives us 4, right? And then again, we're going to square root both sides, but don't forget what, people. And yes, you will say plus or minus, which I'm glad you all say that. Okay, which gives you plus or minus 2 equals x plus 1. And then, okay, well, we can subtract this over, but fundamentally, this is 2 equals x plus 1, and -2 equals x plus 1. And then that means that we have x equals 1. And x equals -3, and those are the two places where we cross our x-intercepts, our x-axis, okay? So bottom line is, all the other info, even though it did take some time to find, we actually could find it once it's here. But if it's not here and they gave it to us in this form, we need to go from that standard form, which is what the top one is called, to the vertex form, which then that truly unlocks your problem and you get all the info you need to graph, okay? And it would plot the points, would draw it, whoop-de-whoop, we're done, okay? But the hardest part is going from here to here, and this is where we're going to focus lecture today. Today, this is what we want to do. We need to go from ax squared plus bx plus c, which is standard form, to x plus h squared plus k, because that would be vertex form. Okay, so we're just going to go ahead and we're going to nail through both of these, and hopefully it'll make sense. Okay, so let's stay tuned for this. All right, well, that's where our lecture starts for today. Or, oh my goodness, we're already in the right notes. All right, so let's go ahead and nail it. How do we do it? Okay, so I'm going to start you off with an easy problem, and I'll write you a cool list of instructions, okay? But I think you guys are smart enough, and I know you guys are pretty sharp, okay? You're pretty sharp here, okay? So, here we go. I want you guys to take a look at this problem, okay? And I'm gonna break it apart a little bit, but I don't want you to write anything down. I want you just to look and check this out. If I have a problem that looks like this, okay? Oops, I kind of gave you a hint. Didn't want to give you that hint. Okay? We all know that squaring it means this. Right? So I'm just basically multiplying this out. And this gives me x squared plus 2x plus 1 plus 2. And then finally you get x squared plus 2x plus 3. Okay? Simple enough, right? So even though we know that this thing has, it could look like this originally, right? We want to get back to this form. But notice something. I want you to notice that on the way to on the way back to get to vertex form, something has to happen here where the two things that are in there, right, they creates a polynomial, this x squared plus 2x plus 1. Now, it was special because that polynomial factors into two factors that are the same thing, and that same thing is then what allows you to write it as x plus 1 squared. Okay? So, we're going to handle this in a kind of a fashion to do it in the same kind of way. So check this out. So I'm going to start from here and I want to work my way back. So this is, and again, you guys aren't writing anything down. You're just looking because this is a pretty awesome way of looking at it, I think. So what if the instructions were put f of x equals x squared plus 2x plus 3 into, I need some more paper, into vertex form. Okay? Okay, well, here's the thing. We talked about this. This is what I want you to do. First thing we want to do is we want to get some space, and I want to push this 3 far to the side. Okay, and you're wondering why I'm going to do that. So what I'm doing is I'm grouping all my X stuff together. Okay? Now, what you want to do ideally, and this is the tough part, so everybody look at this because this is the part where you lose everybody. Okay, and I'll write you a list of things that you need to look out for the next time around. Okay, we want to put in the number. For some reason, I think my finger doesn't activate anything on this thing. Hold on a second here. So I want to put in a number in such a way that when I put it in, and I'm going to add it in, always going to add it into this thing, I think. When I add it in, now whatever that number is that I add in, it should allow this thing perfectly to factor. It should allow it perfectly to factor, but not factor any old way. It's got to factor into two factors that are the same, so I can say those factor squared. Okay? Because remember the goal. We want to go back here. Okay, so what's the number? Well, if you look here, it's 1. You know it's 1. You multiplied it out to get there, right? But how do we know it's 1 here? Well, here's the trick to it. Okay, that number, and that's a sidebar conversation. So this thing in yellow, we'll put here. Okay, so once this thing, okay, and note, this is a special guy because the number in front is 1. We're going to talk about what to do when the number in front is not 1. We got to start here first because this is where it's a little trickier. Okay? How do we find that number that goes there? Okay, well, what you do is you take the b term, which is this thing, the 2. Okay? And what you do is you take b, you divide it by 2, and then you square that guy. And what that allows it to happen is it gives you a number that will make that thing beautifully and complete. Okay, so what that means is that when you put that number in there, that 2 in there for B, come on, don't hurt yourself. That 2's in there for B now. Okay, so this is the come on. The computer won't move fast enough. Okay, so that's the 2 we just put in there. I just want to make sure I highlighted which 2 it is. Well, that ends up being 1 when it's all said and done. So this tells me that this number needs to be a 1 in order to factor it into 2 terms that have to be the same. Okay? That's crucial. Because now, with that number being a 1, I know it's going to factor. But hold on. Everybody hold your horses here. Okay? So, I just put a number in. that's weird. You can't just put a number into stuff. That doesn't make any sense, okay? Because if that's the case, I could just add 1 and then walk away. No. We have to balance things out. This is not an equation. It's an expression. I can't just add 1 to it. Now it's 1 bigger. That's not what I want to do, okay? So here's the idea. I want to put in the number that has no value, okay? So the only number I can add to stuff that has no value is goose egg, 0, okay? But hold on. I need this 1. I need this 1. So this is what we're going to do. We're going to forcibly put the 1 in there. Watch this. And that's why we needed so much space between the 1 and the 3. That plus 1 that I'm putting in, at the same time, I'm going to subtract out 1. And you're saying, Resh, why did you do that? I need this 1 to be here, okay? But to balance out that 1, I'm going to take away 1 and throw that minus 1 onto stack it onto the 3, and then that will figure itself out. That'll simplify down. But this allows me to get the number that I need in the place that I need it. Okay, so now, once that happens, now this thing factors beautifully into x plus 1 times x plus 1. And this is going to simplify to plus 2. And then I can write this as x plus 1 squared plus 2. And then, boom, we're in vertex form. Really simple, right? Yeah and no. Okay, so for example, I'm going to draw some things to your attention. Okay, and this is very, very important. So this is the intricacies. That 1 we put in is this one right here, right? Is this one right here. Okay, this is just leftovers. It gets simplifies down. That just drops off. So that's going to be the up-down shift when we do it. This thing, though, okay, now factors into that. So where did this 1 come in at? Well, turns out that 1 is the number that's in here before it simplifies. So I'm going to let you guys figure that out. Okay, we're going to do one more like this, and then you guys can see another one that's not the same as this. Okay, and you can pick up some more patterns here. Okay, so this ends up being 1 squared. Oops, and that erased out. All right, so bottom line is this is now in vertex form. So the idea is I want the coefficients. All right, so step 1. Okay, is I want the coefficient on x squared to be 1. Okay, that's actually what the problem started with, hence why I highlighted the 1. Okay, then after that's the case, we need to put in the number that completes the square. Completes the square, because that's what it's called when you actually take something from standard form into vertex form. It's called completing the square. Why? Because you're getting the same thing twice. So you can write it as the same thing squared, right? Complete the square. Okay, so put in the number that completes the square. Okay, and we'll talk about when the coefficient's not 1 with the next 2 examples to come. This is going to be a longer video, guys. Just letting you know. Now, so simplify down. Simplify down. Okay, so check it out. Let's do another one. Okay, so that's basically it every single time. All right, so let's pull it up and let's do it again. Okay, I'm going to give you another one. Here we go. Let's say we're trying to put this guy into vertex form, okay? So f of x equals, let's say, x squared plus 4x minus 6, okay? Well, that's pretty easy to do, I think, right? So, first things first, is the coefficient on x squared 1? Absolutely it is. If you look at it, I see it there. Well, I don't see it there, but that's why. It's 1. So life's good. So next step, what you want to do is just give yourself some space, okay? Give yourself some space. And what you're doing is you're getting ready to put in that number that's going to complete the square. All right, so how do you figure out what that number is again? Well, if you remember what I said last time, you take the middle coefficient, which is this b, which is that 4, divide it by 2, and then square. Actually, can we change this number? Because it happened again. I didn't want it to be like that. It was so nice. It did. Let's make it a 6. You'll see why. Because if you take 4, you divide it by 2 and square it, you get 4 again. And that's a different, that's not what I wanted y'all to see. I wanted y'all to see something special. So I want it to be 6. So let's take a second and back it up a second and make a 6. Okay? So now we're still going to do the same thing. We're going to take the b here. We're going to divide it by 2, and then we're going to square it. But I want you to keep track of a few things for me. Okay? So when we take the b, which was 6, and we divide that by 2, then effectively, what we end up with is 3. Okay? And then finally, that ends up being 9. Come on, come on, come on. I'll be moving on my computer too hard. Okay, so the number I need to put in that will complete the square will be plus 9. And to balance it out, I'm going to take 9 out immediately. Okay? And why? Again, I need to make sure it's 0. Now check this out. This thing, if you factor it, it's going to factor into x plus, and I'm writing this small because I want you to see something, x plus 3 times x plus 3, which is x plus 3 squared. Isn't that cute? So, why am I saying isn't that cute? Because this 3 already appeared somewhere else. Okay? B divided by 2, right? Gives you that. So it's good to know that whatever this is. Why? Because it could be the ugliest looking number ever and then like 5 halves. And you have to know what that is by factoring it, because then the factors are just all wonky. Okay, so it's a tricky thing to do. Sorry guys, touching everything. All right, and then so finally we're going to simplify it all down on the outside, and we end up with this. So I put in the 9. This thing factors into that, right? Y, and I know it's going to have it. Boom, x plus blank is that. And now the problem finally starts. Now I know what the vertex is. The vertex would be opposite of 3, negative 15. Axis of symmetry would be x equals negative 3. Okay? And then, how long? Oh my goodness, we're already at 20 minutes. Okay, x equals negative 3. And then finally, you can go through and you can find your x and y intercepts. I'm not going to do that again because we already did it a couple times. All right, guys. So it's a really easy process, okay, when that coefficient is 1. All right, the next video will be a shorter video, but it will be when the coefficient is not 1. And it's important because it's a little trickier. And I'm going to assume you guys have had some practice on these by then, okay? So keep your head up. And if you're going to go someplace you've never been, you're going to have to do some things you never did. So I will ring you back on the next video on part 2 of completing the square. Alrighty.